Hiya! On today's episode of Preaching to a Seven, we'll have a look at yet another integration question. This time around, we have a question from Hong Kong. So, let's look at this fearsome looking question. Part A asked us to derive an identity. So, let's get straight to it. This is what we have to prove. So, we'll start with either the left-hand side or the right-hand side. I would start with the right-hand side. Starting with the right-hand side, we can identify a substitution that we can use straight away. If we let u equals to pi minus x, du is therefore negative dx. When we change the variables, we also change the bounds. The bounds for x are 0 to pi. Therefore, the bounds for u will be pi to 0. How do I find this? It is simply pi minus 0, and over here it is pi minus pi. So I replace x with the upper bound and the lower bound. This guy becomes f of u, lower bound, upper bound. Du is negative dx. We can take the negative in front of the integral and use this to then change the upper bound and the lower bound. Since we are integrating the same function over the same bounds, you can rewrite this as the integral from 0 to pi of fx dx. And that is the end of part A. It does not matter the variable in which to integrate as long as you're being consistent. Part B. We would now like to use this result to find the integral. Okay, so from part A, we proved that the integral from 0 to pi f of pi minus x dx is equal to the integral from 0 to pi of f of x dx. Let f of x equals to x sine of x divided by 1 plus cosine squared of x. F of pi minus x is therefore pi minus x times sine of pi minus x divided by 1 plus cosine squared of pi minus x. Sine of pi minus x, that is equal to sine of x. Cos of pi minus x, that is negative cos of x. So this will give you pi minus x sine of x divided by 1 plus cosine squared of x. Why do we do all of this calculation? That's because we can now use this result. This guy is intimidating on its own, but what if we let this equal to I and then calculate? So we know that I is going to be the integral from 0 to pi of x sine of x divided by 1 plus cosine squared of x dx. We also know that I is equal to the integral from 0 to pi of pi minus x sine of x divided by 1 plus cosine squared of x dx. Therefore, if we add the two, 2I is therefore equal to pi sine of x divided by 1 plus cosine squared of x dx. Beautiful. And from here, we should be able to bring it home. Let u equal to cos of x. Du is therefore negative sine x dx. The bounds for x are the 0 to pi, so the bounds for u will be cos of 0 and cos of pi. This integral now becomes from 1 to negative 1 of pi times u pi. This integral now becomes the integral from 1 to negative 1 of pi divided by 1 plus u squared. Upstairs, we have negative du. Take a negative out and change the order of the bounds. We should all be able to recognize that this is arctan. And when plugging in the bounds, we shall get pi squared divided by 2. Since 2i is equal to pi squared divided by 2, I is therefore pi squared divided by 4, and this is the end of the question. Pretty elegant one.